Sure. Welcome. I'm Mark Scott, Chief Catalyst at SQLSoft3. I wanted to thank you for allowing us to take 30 minutes of your time this morning. Our presenter today is Mike Culver. Mike has worked with databases and SQL Server for more than 25 years, and he's one of SQLSoft3's lead instructors, where he brings his extensive background to the classroom. With that, I'm going to turn it over to Mike.
Thank you, Mark, and hello, everyone, and a very pleasant good day to you, wherever you may be. Today we are going to be talking about SQL Server high availability and disaster recovery through the use of SQL Server Availability Groups. Here is our agenda for the next 30 minutes. We're going to be discussing business continuity principles in general for just a moment, and then specifically we'll get into availability groups, what they are, and distinguish between disaster recovery and high availability. Take a moment to talk about other means of business continuity, such as database mirroring and clusters, how to implement high availability and how to implement disaster recovery, and one of the nice features about SQL Server Availability Groups, the read-only secondary. So let's dig right in. Why business continuity? Well, here in Seattle, where I live, we have this huge mountain that you see out into the south on a clear day called Mount Rainier. And Mount Rainier is an active volcano. And let's say that we have an enterprise application hosted in a data center here, and one day Mount Rainier erupts. And so we have enterprise users all over the world that can no longer access that application. What are we going to do? So to be proactive about such a scenario, we might have our application in multiple data centers, but we're only going to have one primary write database. And so we will need to fail over that database to another data center should the primary become unusable. And so that's the situation we are dealing with here. How to continue the business when we can no longer access the database. SQL Server Availability Groups are defined as a group of databases that fail over together and fail back together. You might have one database in the availability group. You might have 3 or 4 or 5 databases in the availability group. They are going to be defined in Microsoft's terminology as the primary replica and one or more secondary replicas. The primary replica is where our writing takes place. So we are going to be writing to that primary replica, those databases in the availability group, and then that data is going to flow in the form of transaction log data out to the secondary replicas. Now, let's just define a couple of terms for just a moment, just in case you're not familiar with SQL Server at that deep a level. The transaction log is a log, a file, one or more files where changes to the database are written. We can back up the transaction log. We can restore our transaction logs to bring our database up to date. When we commit a transaction, we are writing that transaction log data to disk so that we persist the data without having to write all of the other table information to disk at the same time, which can really slow things down. By only writing transaction log records to disk, we've persisted it and we're still keeping things fast. So these secondary replicas that receive this streaming flow of data from the primary are our failover targets. We are going to fail over to one of these and make them the primary at failover time. These are not backups. We are still going to want to have a backup strategy. I mentioned that we can back up the transaction log. When you back up the transaction log, you are also truncating the transaction log and hopefully keeping those files of a manageable size and reusing that space. So you're still going to want to have a backup strategy, but in the old days we might have just backed up to tape, put the tape on the shelf and the shelf on a shelf in the same data center. where our database server is located, and left it at that. But we are now going to also write the data out to secondaries that may be spread out all over the world and fail over to them when the primary goes down. Now, what detects the health of our primary replica? And if we choose to have an automatic failover, what initiates that primary failover from the primary to the secondary? That is the Windows cluster service. All of these server nodes that we are going to have in the availability group are nodes in a cluster. The cluster is a little bit different, which we will see in just a moment. So we have a SQL Server primary in a data center talking to another SQL Server, this fast streaming flow of transaction log data to the secondary replica where it is written out, and we can fail over to that. That fellow in the middle there is my co-presenter today. If you hear him bark, that means I've said something incorrectly, and we'll correct it. So availability groups are just one of the business continuity options that we have with SQL Server, and I mentioned these are nodes in a cluster, but the cluster is a little bit different from the traditional SQL Server cluster that we're used to. In a traditional Windows failover cluster, we have two or more nodes, two or more computers connected to shared storage. It used to be you could only connect directly to the shared storage. Nowadays, of course, it might be network storage, and the server nodes might be anywhere. They could be on opposite sides of the country if we have a fast enough connection between them. That is still an option. The shared storage failover cluster fails over when a computer fails, but the storage can still be shared. The database mirroring is what we used to use. Availability groups are now a next generation successor to database mirroring. Database mirroring was deprecated as of SQL Server 2012 and will be removed in a future version. I don't believe Microsoft has said which version yet. And so at some point, availability groups may be our only option. But if you have a version of SQL Server 2012, 2014 even, or earlier, you can still use database mirroring. Two copies of a single database, one on a primary write server, one on a read server. You were either synchronously or asynchronously transferring data between them. We might have a third server, which is a witness server, which monitors the health of them. So in this case, the server nodes are not members of a cluster. And also one important point is that our standby server, our secondary server in database mirroring, is not readable because it's constantly in a restore state. And one final database continuity, business continuity option we have, of course, is the old, tried, true, tested log shipping. Log shipping has been around, I don't know, probably since SQL 7 or something like that, which was, 1997? Log shipping is where we're just backing up our transaction log as part of our normal backup schedule. If, many database administrators have created a backup schedule of the log of every 10 or 15 minutes. And then we're just going to be taking that transaction log backup and restoring it to other servers. So usually that involves backing up the log, taking the backup file, copying it across the network to another server, and then doing a restore. And that where we have a warm standby server that is within the backup period of time of the backup latency period of being up to date. So if we're backing up every 10 minutes, we're within 10 minutes of being up to date. Windows failover clusters can look like this. We can use SQL Server as the cluster resource, which means when we fail over from one server node to another, we're failing over the entire SQL Server instance. All the databases on that SQL Server instance get failed over. So the current write node in the cluster fails. The cluster service detects that, fails over to another node according to the rules that we set up. which node that is, and the SQL Server service goes through a database recovery. This can take several minutes depending on how much activity was taking place at the time of the failure, but the SQL Server is what we're interested in getting back up as quickly as possible. If you're in a hosted environment, or you may have elected to do this just as a good practice, a virtual machine or a set of virtual machines running in a hypervisor may be your cluster resource. With Microsoft's virtual machine, Hyper-V, we might have a Hyper-V replica and we're failing over that entire thing. That's another possibility. Of course, you pay the price with running in a virtual machine of the CPU and other resource required to maintain that set of virtual machines, and that definitely has a cost associated with it, but a lot of administrators really like it in spite of that cost because of the ease of administration. Again, we have shared storage, so just one set of storage, perhaps a very sophisticated RAID array or something to guard against disk failure, and each server node takes ownership of that shared storage for write. And we have the cluster service providing us with a single network name and IP address, or many IP addresses, potentially, to talk to the current active node in the cluster. That network name points to the current active node in the cluster. And with availability groups, the availability group is the cluster resource. When we fail over, we're failing over all of the databases in the availability group and no more. We have separate SQL Server instances running on each of the servers and each of the replica servers, and they are receiving that stream of data from the primary, so that when we fail over, it's just a matter of bringing the secondary online for writing. Hopefully that's a very fast process, but that will depend on how many databases we have in our availability group. And the difference in the cluster configuration between this and the SQL Server cluster is each server node has its own independent storage. So this means also that you can cut down potentially on hardware costs if you know that if you have to fail over to a secondary, it might only be a short-term thing. You don't necessarily need as robust a server for a secondary replica as you do the primary. You can have just a smaller server, smaller storage resource available, smaller CPU resource available. As long as you can run SQL Server, have all of your clients attaching to it and writing to it for a period of time until you're ready to fail back to the original primary, you're good to go. So the availability group listener is also a single network name, and that your clients can use to talk to the availability group, and we will be going through that in more detail in just a few minutes. So high availability and disaster recovery, the two aspects of business continuity that we're talking about. What is high availability with regard to availability groups? Well, this writing, this stream of data that we're writing from the primary replica to the secondaries, in this case, is a synchronous write. And what that means is that when we have a transaction being a single unit of work that must either be 100% successful or is completely a failure, 0% successful, and it might be modifying one row, it might be modifying thousands of rows. So when we have this unit of work, this transaction, and we write it out, the last thing that gets written out to the transaction log is success. This is a success, and that is a commit. The transaction is committed. So when we have a synchronous write from the primary to the secondaries, we are going to commit on both the primary and the secondaries, and they're all going to tell each other this is committed before the transaction is considered to be a success, and you tell the client, hey, this was a success. Now, if you're writing this transaction out to a bunch of different servers and it's got to succeed in all these different places before it's considered committed, of course that means increased transaction latency. Your users may notice a delay, a slight delay hopefully, but a delay nonetheless, and you may be using up more resources on your primary SQL server the longer that that transaction is in progress, because you've got locks being held, you've got SQL Server resource being used managing the locks, who's in the locking queue, you've got readers waiting for writers, you've got the writer, you've got writers waiting for the writer. So that all can have an effect, not just the users noticing a bit of a delay. When you fail over, you can designate one of these synchronous write secondaries, and only one, as an automatic failover target. The Windows Cluster Service keeps an eye on all of the server nodes in the cluster, the primary, and takes and monitors the health of the primary. When it detects that the primary is no longer available according to the rules that you set up for monitoring the health of the cluster, it will initiate an automatic failover if that's how you have your availability group set up. So the old secondary, synchronous write secondary, is the new primary, and if you fix your old primary, whatever was wrong with that, and reattach it to the availability group, it will resync, and now your old primary is the new secondary, your old secondary is the new primary. You can fail it back at that point if you wish. If, for example, your old primary has a lot more resource available than the new primary, and you want to make that available to your users, then you could then fail it back. What without data loss means is that there are no committed transactions are lost. Transactions that are in progress may be lost. They will be rolled back. And you can have rollbacks for any number of reasons. You may have rollbacks in your code if the data being presented does not match business rules or something like that. SQL Server can deadlock on a couple of different rows in an index or something. And so many reasons why rollbacks occur. This then just becomes one of them. A transaction in progress can roll back. That's not considered to be data loss. You just repeat the transaction. So you can also manually fail over a synchronous write high availability group. You can just say, after this point, no new transactions will be accepted. That once the transactions in progress have committed, you manually fail over. All the committed transactions are written out to the secondaries without any data loss. Let's distinguish that from disaster recovery. With disaster recovery, where we have secondary servers that now are not hot standbys, they're warm standbys. We are asynchronously transferring data to the secondary replicas, which means that the transaction commits on the primary, and if we are writing out asynchronously, it commits in all places, but the transaction is committed before we transfer it to the secondary replicas for which we have asynchronous transfer set up. So this means then that we can only manually fail over to a secondary when we're asynchronously writing, and we do have the slight possibility that we might lose some data, and here's how that might work. Let's say that we have a transaction that commits on the primary replica, and it's committed on it is committed in the transaction log, but before that transaction log commit record can be written out to a secondary, the primary goes down, and the DBA sees that, commences the failover, because this is a manual failover situation only with asynchronous writes. So it's either going to be done by a person or in some code somehow. And so the failover commences before the secondary has received that commit record, and that's the only possible way that you can lose data in this situation. Transaction commits on the primary, that commit message is not received by the secondary, and so when the secondary recovers that database for writing, it rolls back that transaction not knowing that it had been committed. Because of our desire to have business continuity for enterprise applications, even if an entire data center goes down, like in our example with the volcano erupting, we might want to have secondary replicas in different data centers, far distance data centers. So we will need a fast enough network connection to do that. If we have a if we're using internet for data transfer, then we will want to have some kind of tunneling, some kind of security set up to get the data from the primary data center to the secondary data centers, or we might just have a private network of some kind. And so yes, we will want to have a fast enough network to do that. We're going to have security to do that, and we will want to open ports for both the data transfer of the log records as well as clients connecting from the primary replicas to the secondary and from everywhere to the secondary. Some hosting providers are offering database hosting, SQL Server hosting, and you can put a secondary replica on a virtual machine. Microsoft is offering this with the Azure hosting. So all of this means then that you are going to be extending your network and extending the domain to this distant data center. All of the replicas must be in the same Active Directory domain in order to be a part of the same cluster. That's a rule, and so you're going to need to set up that security to extend the network and then extend the Active Directory domain to those distant locations, and of course everything that goes with that from an infrastructure point of view. You're going to want to have backup domain controllers in those distant environments. You're going to want to have DNS servers in those distant environments and everything that goes along with that. That said, once you have the distant data center set up, you initiate a failover. Your users using those clients all over the world can then reconnect and continue their work while the primary data center goes through its repair and comes back online. The availability group listener is a feature of the cluster service that allows a single network name and IP address to be associated with an availability group. So if you have many databases in the availability group, you assign that single network name, and it can be more than one IP address. You could, because you may, with all of these distant data centers and so forth, you may have server nodes on different subnets. You can have an IP address on every different subnet that you wish, and a single network name that is resolvable in your Active Directory DNS, and you can that network name then points to whichever server is the current primary replica. That is done by cluster services, points the network name at the current primary replica. Your client logs in, and you can use any of the databases in the availability group. When you have a failover, the action of reassigning which server the IP address and the name points to is done in the background by the cluster service. So this is great from the point of view of the logic that you're building into your clients. Your clients only have to know that one network name. And if you were using database mirroring, for example, the clients have to know the name of the primary and the name of the secondary. And you need, you might want to say, if I can't connect to the primary, try to connect to the secondary. If I can't connect to this secondary one, try to connect to secondary two, then go back to the primary. You don't need all of that logic for retrying in your clients. Your clients just, all they need to know is just the one network name. And cluster services takes care of everything else. So the full topology will look something like this. We have a SQL Server primary replica in one data center with its own independent storage. A tunneling protocol or a private network or something is being used to connect it, and that should read on Data Center West, the secondary replica. And so the writes as they occur on the primary might synchronously or asynchronously take place on the SQL Server in Data Center West, the secondary. How fast that network connection is will determine whether or not that can be a synchronous or an asynchronous connection. When we fail over to the secondary, the availability group listener automatically redirects client requests to go to that secondary. And it's a great feature and keeps your data available as long as and as quickly as possible. So one of the nice features of having that availability group listener is that we can do some load balancing between reading and writing. Why would we want to do that? Well, when you have readers and writers mixing it up in the same SQL Server database, SQL Server has to manage blocking logs. So it has to manage the lock, who's in the locking queue. Writers block readers, readers block writers, writers block other writers. But if we can minimize that and have read-only clients connecting to a secondary replica for the purpose of reporting and so forth, that can help minimize the number of locks being held and the resource SQL Server has to use to manage who is in the locking queue. And especially if your users are running complex reports that do aggregation and that kind of thing, you know, that can be a lot of locks being held all at once, and your writers are sitting there waiting while that takes place. But if those read-only reporting clients can connect to a secondary replica, you can have multiple clients that are read-only connecting to a secondary replica, and they aren't blocking each other. They're all doing their thing. And so that achieving that degree of load balancing can be a great savings in server resource. You can configure your secondary replicas to accept read-only client connections as part of your availability group setup. And then when you log in from your .NET client, depending on the version of .NET that your clients are using, you can specify a connection string property that says this client is read-only, and assuming all of the other availability group configuration has taken place, they will be automatically directed to a secondary server for that reading. And you can also maybe have those read-only clients connecting to a secondary replica that's close to them. That's another possibility. If you have them all over the world and data centers all over the world, that's a configuration you can do.